everyone. Welcome to Fibocast, the go-to podcast for thought leaders, engineers, and tech enthusiasts in the telecommunications industry. In Fibocast, we dive deep into transformative technologies that are shaping the future of connectivity, from groundbreaking 5G communications to the unlimited potential of artificial intelligence and the Internet of Things. We explore how these innovations are transforming the way we communicate, operate, and grow. My name is Parkin-White. I'm the co-founder of market analysis and consulting firm TecFutures, and I'm the host of today's Fibocast on exploring the potential of 5G RedCap. Today, in this episode, we have David Palma to join us. Hi, David. Could you please introduce yourself and tell us about your role at Fibocom? Over to you.
Hi, Andrew. Thanks a lot. And good morning, everyone. So I'm David Palma, and I'm a technical director at Fibocom. And I'm responsible for the technical innovation and partnerships, plus pre-sales and technical support.
Thank you, David. So we've got quite a wide-ranging discussion ahead today. But first of all, I thought we could start with looking at a brief overview of what RedCap's all about. So the introduction of reduced capability, or RedCap for short, into 5G networks looks to create a transformative opportunity within the IoT sector. RedCap is a streamlined version of standard 5G and targets IoT devices that require lower data rates, optimized power usage, and less connectivity needs. And essentially, it's bridging the gap between high-performance 5G and lower power LTE solutions like LTE-M and NB-IoT. So, David, I'd like to get your perspective to give us a brief overview of what RedCap is to kind of set the scene.
Yes, sure, Andrew. So maybe we could start by explaining why RedCap has been created by the 3GPP. Andrew, as you well said, RedCap is a technology that bridges the gap between a low-power area protocols such as Cat-M and narrowband IoT on one side, and on the other side with 5G. So RedCap has been created to be a compromise between low latency requirements, high bandwidth capabilities, and also to meet the requirements of being able to connect a large number of devices to the network.
Thank you, David. I think we'll pick up on a few of those themes in more detail a little bit later on. I thought we could sort of take a step back now. As a market analyst, I tend to like to see the dynamics of the market, and thinking about IoT market evolution, we do see that IoT is obviously a growth market. We've seen fantastic growth rates over the past few years, and analysts estimate that by 2030 there'll be around 30 billion connections. But it's a market that's changing, and I'm interested in how RedCap fits into this, and we'll talk about that shortly. But for what we're seeing, IoT is moving to new areas, new applications, different applications within verticals. We're also seeing there are less sophisticated customers coming on board. It's like any other market. As it develops, you get your sort of early customers who are quite tech savvy, and now we're moving into a market where these customers don't have the same sort of technical abilities. They can't manipulate through IoT for their own needs. It's a more mainstream market. And as you're saying, David, not all applications are equal. If we look at the market, we're seeing some sort of applications which are intense users of video, high bandwidth, low latency type applications, and others, if we're going down to examples like smart metering, which are quite sophisticated. So I was just wondering how you see RedCap fitting into the IoT market expansion over the next 5 years.
Yeah, sure. As we said earlier, RedCap is addressing intermediate use cases between 5G and LPWA. So there are many types of applications that may use RedCap. So we can consider applications such as smart metering, like electricity meters, water meters, gas meters, for instance.
Yeah.
But also in the industry and the manufacturing and the automation with the Industry 4.0, where there is an extensive usage of sensors which doesn't need high bandwidth, but may have certain requirements in terms of low latency that RedCap can address. Healthcare, and by extension, I will also speak about wearables. So where patient monitoring in healthcare can be also a target market, and wearables as well, because RedCap brings interesting features in terms of power savings, power consumption, and as a consequence, longer battery autonomy. And I would also mention IP cameras, because they perfectly fit into this medium range of bandwidth requirements, where RedCap, which delivers something like 200 of megabits per second, IP camera is more than enough. I mean, these bandwidths are more than enough for IP cameras. And last but not least, in some markets, and I would say emerging markets, RedCap can be seen as a low-cost 5G fixed wireless access. So 5G routers that will bring 5G connectivity to households in emerging countries.
So it sounds like RedCap's got multiple applications, and I just wanted to take a little bit of a step back, and again, putting my market analysis hat on and looking at some of the numbers around 5G. So the 5G IoT market is projected to experience rapid growth, and we estimate that 5G IoT will be growing from around 25 to 30% compound annual growth between now and 2030. And this growth is driven by some of those verticals and applications that you're talking, and things that spring out that we were discussing are automotive type applications, a huge market for IoT, industrial IoT, manufacturing, etc., healthcare, smart cities, and smart grid type applications that you made mention of using RedCap for utility type applications.
Yeah, totally agree, Andrew. I would add to your comments that beyond the targeted use cases we mentioned earlier, we also need to take into consideration the market landscape, where we all know that 2G and 3G networks will be disconnected sooner or later. And RedCap can be a migration path for devices currently using 2G and 3G networks.
Yeah, it looks like to me as an external observer that RedCap's likely to capture a significant portion of this 5G market growth by providing cost-effective solutions that meet the requirements of those sort of mid-tier and lower-end IoT devices. And the point you made on 2G and 3G sunsetting, again, we sort of see as analysts there are kind of so many technologies out there, and it's hard to predict which are the winners and which are the losers. But looking at sort of market estimates, it's looking very much like by 2030, RedCap's going to account, 5G RedCap that is going to account for about 30% of the cellular IoT market. So making quite a lot of progress and capturing high value applications. And it's going to account, even though it's 30% of the market, we reckon it's going to account for around 50 to 60% of cellular IoT revenues. I'd just like to take a little step back, and we know that RedCap is performing differently or will perform differently in different geographies. So I'd like to just pick your brain, David, in terms of where you see the key geographic markets for 5G RedCap.
Yeah, without being too technical, you need to know that RedCap relies first on the 5G network, but these 5G networks needs to be what we call a SA, so standalone 5G network. And if you look a bit back in the 5G deployment history, many carriers have started with non-standalone 5G network deployments, especially in Europe. And this NSA does not support RedCap. So one of the necessary condition to see the RedCap growth is to have carriers to implement SA standalone networks in Europe, while in other continents like China and in the US, many carriers have already started to deploy SA networks, and they are already RedCap capable. And there are even some commercial networks being launched very soon in RedCap. So this is why in Europe, we are lagging behind due to the delayed SA network deployments. But looking at 2025, we can be optimistic. So currently, there are already 15 SA networks deployed in Europe. So it means that those networks are ready to support RedCap. Doesn't mean they are ready today, but they will be soon. And there are 45 more networks that are today under planning or field test for SA networks. Talking to carriers also, they all, they tell us that 2025 is the year where we will see RedCap taking off.
In summary, you're seeing that the market is sort of taking off in some areas of Asia Pac, that Europe will come online in the next couple of years once the sort of proof of concept has been established and European carriers start to see the benefits. Is there anything happening in other areas like North America?
Yeah, North America is definitely ahead of Europe, and as well as China also is pretty well advanced compared to Europe. So they already have the SA networks deployed there. So now they need to roll out the RedCap feature onto their SA networks.
So moving away from markets and geographies, we've touched on this already, but I think it'd be good to get a real feeling of the key capabilities of 5G RedCap. I'm thinking particularly in terms of network compatibility, hardware design. I'd like your thoughts on that, David, if you please.
Yeah, that's a good transition because we can say that, first of all, RedCap is a 5G technology. So being a part of 5G technology, it means that this is a future-proof technology, and definitely carriers will bet on it in order to concentrate all their customers, being consumers with smartphones, but also IoT devices on a single 5G networks, which will allow them to reduce operating costs and so on. Regarding RedCap from a more technical standpoint, so we say that RedCap is a reduced cost compared to regular 5G devices. So we can maybe spend 2 minutes on how this is achieved. First of all, the main driver of the cost reduction is due to the RedCap devices architecture that has been made more simple compared to a regular 5G device. So this means, in fact, an RF, so radio frequency architecture that has been made very more simple with lower capabilities, sure. Less antennas required. So in a regular 5G device, you can have up to 8 antennas. In a RedCap, it's 1 or 2 antennas. You have reduced MIMO capabilities compared to 5G. There is a lower modulation scheme, so over the air, meaning instead of having 2 modulation scheme, RedCap only uses the 64 one, and also reduced bandwidth, so 20 megahertz instead of 100 megahertz. Combining all this, so it makes the devices more simple and for sure cost effective because you need the less powerful components inside the 5G device. And the other consequence is that the power consumption also is reduced compared to a regular 5G device.
Yeah. From what I understand about IoT applications, there are quite a few of the applications that RedCap will be suitable for that are a long time in the field. And I think sort of that, like the hardware design, the form factor of devices is an important consideration also for 5G RedCap. Do you have any thoughts on that, David?
Yeah, for sure. As I said, there are less number of antennas required. So this is more simple for customers to implement RedCap into small devices. And considering field devices operating on batteries, as I said, the simplified architecture leads to optimized power consumption. So when we talk about wearables or devices operating on battery, like tracking devices for containers and so on, you can expect better performances compared to legacy technologies from an autonomy standpoint.
Thank you. I mean, it does sound as though we could call RedCap the sweet spot of 5G, and it does appear to have some real advantages over previous connectivities. As you mentioned, it's a cost-effective alternative. It's probably more suitable to those less sophisticated customers. Cost is always a key driver, and optimized cost and power efficiency and a simpler architecture reducing the hardware, network, and device complexity all lead to cost savings, which is what the future customers of IoT will like. But there are a few other sort of distinct advantages of 5G that I'd like you to comment on. We probably covered them briefly, but things like the balanced data rates, supporting mid-level data speeds, the extended battery life, power consumption, and how it plays to devices that must operate independently over extended periods, and wider network capability and interoperability with 5G networks, and particularly support for 5G features like network slicing and LAN. So it'd be good to get your thoughts on a few of those sweet spot issues that will drive 5G RedCap.
Yeah, right. You're totally right, Jean-Luc. RedCap, as I said, is a 5G technology, and it benefits from the 5G features. So network slicing is one of them. So the network slicing is the capability for the network to provide you a customized quality of service in order to meet your device requirements, be it speed, so the data bandwidth, or low latency, or massive machine type communication. So a lot of devices in a given area communicating at the same time. And this is why I said earlier that RedCap is a future-proof technology, because this is a 5G, and this is because it benefits from all the 5G services that will be marketed by the network carriers in the coming months. Regarding balanced data rate, we all know about 5G capabilities, and we are talking about hundreds of megabits and even gigabits when we talk about fixed wireless access on 5G SA networks. With RedCap, we are far below those values, and we are addressing the mid-tier market, which is between some megabits to 100, 150 megabits. So this can address a very wide range of devices, from very infrequent communication from sensors up to high quality video surveillance.
We've talked about some of the numbers in terms of market growth, but there is another picture emerging. We can look at the market growing at 20, 30% a year, but also the data traffic is growing at a far, far greater rate than that. And obviously that comes at a cost. So I'd just like to spend a couple of minutes to get your views on how companies can achieve cost reductions and power savings with RedCap. Is there something particularly around the technology that creates these cost reduction and power saving advantages?
Yeah, the simplified architecture that I explained earlier leads to less power consumption. But I should also add that RedCap also implements features that are well known in low power wide area solutions like LTE-M and narrowband IoT, as it implements, for instance, what we call extended DRX, which allows to decrease significantly the power consumption. And on top of that, on the network side, there are, let's say, signaling optimization, especially when it comes to link measurements. So when a device connects to a 5G network or 4G, there are constant communication between the device and the network in order to measure the link quality between the device and the network. And those measurements consist in exchanging data back and forth. And for sure, the more you communicate data, the more you consume power. In RedCap, those measurements has been reduced in order for further power savings. So add more autonomy to the devices.
Yeah. And of course, standardization has a role to play in driving any market. How is the standardization progressing for RedCap?
So RedCap has been introduced by 3GPP in the release 17, which has been made official back in 2022. So this is the current technology that you can find on the market. So chipsets modules are based on RedCap release 17. There is RedCap, what we call an evolution of RedCap called eRedCap as enhanced RedCap that has been specified in 3GPP release 18, made official earlier this year. And this new standard will enhance the simplification of the RedCap devices. So instead of implementing a 20 megahertz bandwidth, for instance, it will be 5 megahertz bandwidth, so less radio frequency consumption. And this will lead again to lower power consumption. So so release 18 will go further into the complexity device reduction, and it will also, as a consequence, reduce the cost. If we may sum up in a nutshell, RedCap release 17 is equivalent to an LTE device category 4, which is in the range of 150 megabits download and 50 megabits upload. The eRedCap planned in release 18 is equivalent to a LTE category 1 device. And so we are talking about download speed of around 10 megabits per second. So looking at the landscape with RedCap and eRedCap, so release 17 and release 18, we will have the 5G, the real 5G standalone with the full speed of some gigabits per second. We'll have the RedCap covering the 100 plus megabits per second. And we will have the eRedCap covering the 10 megabits and lower type of devices.
It's clear that maturing standards are very important, and standards do facilitate expansion into new IoT applications, different geographies, and drive adoption in other sectors. And we've mentioned some of these sectors already, such as smart wearables, industrial sensors, medical devices. And it seems that growth is going to be driven by some key sectors, verticals, applications, such as manufacturing and automation, smart infrastructure, healthcare, smart cities, etc. I'd like to just pick up sort of earlier on, David, you mentioned 5G fixed wireless access, or FWA. Could we just dig a little bit more into the 5G FWA opportunity with RedCap?
Yeah. So we currently see an evolution of this market. So fixed wireless access, just to make it clear, is addressing the devices which brings you connectivity at home. So the local loop that have been used in the past used to be copper with ADSL, for instance, years ago. More recently, optical fiber to bring internet at home, for instance, or to connectivity for companies. And more, we see now the evolution of this market towards totally wireless devices, meaning no more copper, no more optical fiber, and the local loop, or the main link towards the network operator, is the 5G network. And this has been made possible with 5G, allowing higher data speeds. So as I said earlier, a multiple of gigabits per second. So this market is now taking off, especially in North America. But not only, we can also see that there is an increasing demand in Europe, and carriers are more and more interested in this type of devices. RedCap here in this area can play a role for emerging markets, so like Africa or India or Latin America, especially because they bring cost-effective devices while it's still a 5G technologies. So we have seen demands from those markets for fixed wireless devices or routers, 5G routers, but relying on 5G. So for sure, they don't have the 5G that we can expect, 5G speeds that we can expect from a regular 5G device, but they provide reasonable speeds at a very good price.
Yeah, that's a very interesting market, and I'm sure there's a lot of growth there. Another one we mentioned briefly earlier on was IP cameras. I wonder if you could just elaborate on the kind of market opportunity for those.
Yeah, for IP cameras, so whether it's for smart cities or homes and so on. So the cameras have medium, let's say, requirements in terms of speeds. They don't need hundreds of megabits of bandwidth, but at the same time, they need a certain level of latency. So the latency cannot be too big. So that's why, again, RedCap is the good compromise between speed and latency that meets this type of application.
Thank you. So In summary, one of the things we look at as analysts and consultants is are all the elements in place for the market to develop for a technology like 5G RedCap? And it certainly seems to me that a lot of those elements are in place. So we have the applications, the standardization process is happening, and the key advantages are apparent, such as device cost reduction and scalability, simplified hardware designs, flexible licensing pricing models, economies of scale, the interoperability with existing IoT technologies, and allowing a seamless transition, particularly in those areas where 5G adoption may be slow or lower. Support for mixed mode developments, and we've mentioned the power efficiency and energy saving mechanisms and the use of advanced chipsets. Now, another area we've sort of touched on is the quality of service profiles, and it's the impact on latency and bandwidth requirements. And I think sort of the key to doing this is to communicate RedCap's key differentiators to the wider market. So I don't know whether you have any comments, David, on how you see those elements being in place, and whether we sort of missed anything that's driving market development.
Yeah, we can complete your picture, Andrew. We can add that the 3GPP spec, the standardization, is not only looking at the 5G as we know it in the consumer market with smartphones and so on, but now is really addressing the needs of IoT devices from low to high end IoT devices. So this is a really key driver for the market growth, and this is establishing the necessary conditions for the ecosystem growth in the future.
Yeah, it sounds like a very good road ahead. I think we're sort of coming to the end of our time today, so I'll hand over to you, David, to say a last few words.
Thank you, Andrew. This has been a very interesting discussion. As a global leading wireless module and solution provider, Fibocom offers a comprehensive of 5G RedCap modules based on the Qualcomm SDX35 and MediaTek T30 chipsets. For anyone interested in learning more, feel free to visit our website at fibocom.com, or you can also reach out to us directly. We would love to connect and share more about our initiatives on RedCap, and also hear about your own projects.
Thank you, David. And thank you for a fascinating discussion. And thank you, everyone, for listening. To hear more, join the Fibocast, Fibocom's new podcast, coming soon to iotnow.com. And look out for more details on the Fibocast on social media and web channels. Thank you, everyone, and goodbye.